I hope you are freely falling in love with physics. So today we are going to talk about free fall. So what is free fall? Freely falling bodies. Right, when something or someone freely falls from a height that no force is being applied on it except the gravitational force of earth, we call it a free fall. Just like space stations are freely falling. I'll tell you about these things someday else. Today we are going to derive an equation and talk about the deflection in horizontal plane when the body is freely falling. You will say that the body is freely falling, it will have uh, deflection in y direction, x direction means vertical direction, but it will also have a horizontal uh, deflection due to Coriolis force. So let's talk about this. First, do you know that the gravitational pull or the acceleration due to gravity is a combined effect of the inertial acceleration and the centrifugal acceleration. Means we can say that minus g I cap. Here I have represent the acceleration due to gravity as minus I cap because the acceleration is towards the center of the earth. If we take this x-axis, this will be minus x-axis, and we know that the gravitational force acts along the line joining the center of two bodies. If a body is falling from here joining the center of two bodies, the force will act along this line towards the center, so it will have a minus I cap direction. So this acceleration is combined effect of inertial acceleration and centrifugal acceleration, that is omega cross r. So this is equation 1. Let us name this as equation 1. We are going to talk about the deflection along the horizontal direction. Let us first recall the equation. Acceleration in rotational frame equals to acceleration in inertial frame minus some pseudo forces, right? That is minus omega vector cross r centrifugal acceleration and minus the Coriolis acceleration 2 omega cross vr, right? So here this term can be equals to this, right? We can say that acceleration in rotational frame is equals to minus g I cap minus 2 omega cross vr. Here let's talk about this vector, vr vector. So what is the velocity? We can say that it will be dx, change in x by dt I cap. Here the object is falling, it will along the negative axis, but still I have not put it any negative direction because the change is negative. So it will dx will have a negative value, and in total it will be minus I cap, right? So here I am not putting the sign of negative, but it will lead us to a negative sign when we put values or put actual situation, right? Dx will be negative, so this term will be total negative and will show that the body is falling in along the negative x direction. And we know about omega. Here the earth is rotating along its axis with omega, uniform angular velocity. So shifting this parallelly to this point, it will have an angle phi with z, that is north direction, and therefore omega will be equals to omega cos phi k cap. Z along z axis it will be k cap. Sorry. Plus omega sin phi I cap. Right. Let us do some cross product. So here if I put omega equals to this and omega cross VR, for VR put this, we will get omega cross VR equals to this thing cross dx by dt I cap, right. So here we can see that I cross I will be 0 as the angle between I and I vector is 0 and sin 0 is 0. So now talk about omega cos phi k cap cross dx by dt I cap. So it will give us the value equals to, sorry, there is a 2. Okay, let's just solve this omega cross here, then multiply it with 2. So this will be equals to omega cos phi dx by dt k cross I is j cap, right. So minus 2 omega vector cross VR vector equals to minus 2 omega cos phi dx by dt j cap, right. K cross I is j minus 2 omega cos phi dx by dt j cap. So now we can take this term to left hand side and say that minus g I cap is equal to acceleration in rotational frame minus this. So let me erase all these things and write everything clearly once again, making this equation minus g I cap equals to AR plus 2 omega cross VR, which has the value minus this. Let me first erase all these things. So now we can say that minus g I cap is equals to, we can say that AR. Let us break the acceleration into 3 components, obviously along x, y and z axis. So we will get, if there is a change or double derivative of change in position, that is d2x by dt square. We know that double derivative of position vector is acceleration. This acceleration is along I cap direction, plus d2y by dt square j cap plus d2z by dt square k cap, right. AR has 3 components now, and we have found the value of 2 omega cross VR was equals to omega cos phi dx by dt j cap, right. So now we can just compare the left hand side with the right hand side, right. Here there is no j or k component, means this value, this plus this value and this value will be equals to 0, but here I cap has the component of minus g, means d2x by dt square will be equals to minus g. So let us just integrate in and try to find the x, means the change along means the change in position vector along x direction, deflection, and let us see what we get. So here I am just integrating d2x by dt square equals to minus g, right? By comparing these two sides, integrating it, we will get dx by dt, means the velocity vector will be equals to minus gt plus c. We know that if we integrate this side, we will get a integration constant because it is an indefinite integration. We have no limits here. So putting this one, this constant, integration constant. Here we know that at time t equals to 0, the body was initially at rest. The body is freely falling, so we have applied zero force on it. We have applied, but a gravitational force is working on it, and we have not just put at some velocity, made it fall with some velocity. It was at rest initially. So at t equals to 0, the value of velocity equals to 0, that is dx by dt equals to 0. If we put this condition in this equation, we will get that, we will get c equals to 0, and finally we will get the equation dx by dt equals to minus gt. Let me first erase all these things. We saw that dx by dt equals to minus gt. Let's integrate it once again. We will get that x equals to minus gt square by 2 plus c. At time t equals to 0, velocity was 0, but the thing was at a height of h. So here x equals to h. Putting this condition in this equation, we will get h equals to minus gt square by 2 will be 0 plus c, means c equals to h. So we can write x equals to minus gt square by 2 plus h. Let us suppose the body has freely fallen and has reached the ground. So when it has reached the ground, the time will be equals to the time period, means the time required to reach ground, and x will be equals to 0 because there is no height, means it is on the base level, means where the height is equals to 0. So putting this condition in this equation, you will get that 0 equals to minus g time period square by 2 equals to h, right? Taking this term, plus, taking this term to left hand side, we will get that gt square by 2 equals to h. From this we can find the time period, means the time required to reach ground. So t equals to 2h by g under root. Means if we let a body freely fall from a height h, it will take time under root 2h by g to reach the ground. So now here we have found the time period, and another thing, that is this equation. This is going to help us to find the horizontal deflection. Let us put this as equation number 2. So now we are going to find about the horizontal deflection. Let me erase all these things. Now we are going to solve for the second term, that is the component along y axis and j component. So here I found that the j cap component was something like this, d2y by dt square plus 2 omega cos phi dx by dt, right? J cap. We had seen that this there was no term in the left hand side with j cap direction. So this thing will be equals to 0. Means d2y by dt square plus this will be equal to 0. So d2y by dt square equals to minus 2 omega cos phi dx by dt. So let us integrate this. We had found in last equation that dx by dt was equal to minus gt. So we can replace it with minus gt. So this negative sign will be make this term positive, right? So let us integrate this. We will get d2y by dt square equals to 2 omega cos phi g t square by 2 plus c. D2y by dt. Putting the initial condition, we can see at time t equals to 0, dy by dt was 0. Means initially there was no velocity along y-axis. So we can see that c will also be equals to 0. You can solve it and see this. So now once again integrating this, we will get y equals to 2 omega cos phi gt cube by 3, 2 has cancelled out, gt cube by 3 plus c. Here it's c was equals to 0. Once again the integration constant will be 0. By putting the initial conditions, you can see at t equals to 0, y was equals to 0. So here I am going to put t equals the time period to travel to the ground level and find the deflection along the y-axis when it is freely falling from a height h. Here the integration constant was equal to 0 by putting initial conditions, and now we are going to put another condition at t equals t, means when it has arrived at the ground, that is time period was found to be 2h by g. The change means the deflection will be equals to y, right? So now let us put in the conditions. Y equals to omega cos phi g 2h by g to the power 1 by 2. 100 means 1 by 2 into 3 means 3 by 2 by 3. So here let us simplify this further. We can take h outside, omega cos phi h to the power 3 by 2. Here 2 we can say that 2 will be equals to, let us take 3 inside, means 2 to the power 3 to the power 1 by 2, right? So we can say that it will be equals to 2 to the power 3 to the power 1 by 2, and taking this g inside, we can say that g to the power, if we take it inside, g to the power 1, here 1 minus 3 by 2, right? So now again take 3 inside this equation, and we can say that 3 will be equals to, if we want to take the 3 into this term, we can say that 3 in, we want to get power of 1 by 2 of these terms. So to get 3 as with some power 1 by 2, we can say just do a square and say that 9 to the power 1 by 2, because root over of 9 is 3. So we just want to get a power of 1 by 2 to these 3 times. Y equals to, so that we can take a common power of 3 times and take h outside, because it will look more beautiful. We can just use this equation, but to make this equation look more beautiful, we are doing just some calculations. Cos phi h to the power 3 by 2. 2 to the power 3 means 8. G to the power 1 minus 3 by 2 will be equals to minus 1 by 2. We know that we are going to take 1 by 2 power common. So we are not considering here 1 by 2, we have taken it outside. 2 to the power 3, 8. G to the power minus 1 by 2. 1 by 2 means G to the power minus 1 by 2 will be equals to G to the power minus 1 into 1 by 2. Here is 1 by 2, where we have to just take G to the power minus 1. So here G to the power minus 1 and 9. Maybe my G and 9 are looking the same, but as I am speaking, you can understand that this is 9 and 9 to the power 1 by 2 means 9. So just write this equation as 8 by 9 G to the power 1 by 2 h to the power 3 by 2 omega cos phi. You know that omega is angular velocity of earth, h is the height from which we are dropping the body, g gravitation acceleration due to gravity, cos phi that is cos of latitude. So we know that at equator the phi is equals to 0. So cos phi will be equals to 1 and therefore the y equals to 8 by 9 g to the power 1 by 2 h to the power 3 by 2 omega at equator, and there is no deflection on both of the poles, because as the when the earth is rotating, the both of the poles are at the constant place, they are not rotating, so no pseudo force due to this, and hence they will have zero deflection along y-axis when freely falling. So these things are observable with small h at equator. So for to experience Coriolis force, actually things have to travel a longer distance. So therefore we had used Foucault pendulum and have to travel a lot like aeroplanes to see these deflections and all. So this is free fall and this is the equations you need to understand. So with this equation, that is the deflection along y-axis, that is each direction due to free fall, I am ending this lecture. In the next lecture we are going to solve some questions that is really very common and will help you to understand more about this topic. So with this, thank you.